that we are going to do is page 104. Okay, so it's about functions. All right, so let's quickly review exponential function because log came from exponents, right? You could change from exponential form to log form. So let's go back, okay, to this one, page 89. Okay, can you raise your hand if you're at page 89? Okay, Samantha, yeah, are you at page 89? So we group the exponential function into two types, right? One is when base bigger than 1, then it will be increasing, right? Look at the top, right? Base greater than 1, it will be increasing. Between 0 and 1, decreasing. And increasing, decreasing is looking towards to the right side. Okay, as we move to the right, it gets higher. We call that increasing. Goes to the right, lower, it's called decreasing. Okay, so same with the logarithmic function. It also has two types, right? So we will be drawing these two and then compare with the exponential graph. Okay, see how they look differently, right? And also one more thing is these two, they have asymptotes, right? Horizontal asymptotes. Equation is y equal to 0. Okay, so for the exponential function, you will also get the asymptote lines as well. All right, so let's take a look. Go back to page 104 now. Okay, so the connection between log function and exponential function is they are inverse. Okay, so that's the key word. I give you an exponential function, right? Look at the yellow highlighted, that's exponential. Then the inverse of the function, okay? The inverse is the log function, okay? So we already know how to read that, right? Log base b of x. And then we have two kinds of base, right? Base between 0 and 1 and base bigger than 1, okay? So think about number line. If I draw a number line, okay, this is all the base. If the base is between 0 and 1, it looks like that, right? Between 0 and 1. If it's greater than 1, it will be starting from 1 and over to the right side, right? So it doesn't include 1. So another way to say this is just to say greater than 0, right? Base is bigger than 0, but not equal to 1. So skipping 1. Okay, any questions? Okay, so instead of saying between 0 and 1 or greater than 1, we could also say greater than 0 means positive, but exclude, right, not equal to 1. Okay, now one more thing is, so this one is the restriction, okay, restriction on the base, okay, and then there is also restriction on the inside, which I mentioned last time, right? Inside must stay positive when we solve the equations, right? Page 99, right? Remember, you see this equations. You must make sure the inside is positive. And the reason why we must have positive, we also explain over here on page 94, right? We went over if it's negative, what happens, right? You couldn't get an answer. If it's 0, right, what happens, okay? So it cannot be negative, cannot be 0, so it has to be positive, okay? So two restrictions, keep that in mind. Now we also need to review the inverse, right? We learned inverse and in the first chapter, how to find inverse, Okay, so I don't remember the page number. It's all the way back. Okay, very first chapter when we learn functions. Um, maybe I can point out to you. Okay, so let's go back, very beginning. Okay, functions. Or it's in the other file. Okay, let me pull it out. Functions is, where did it go? Oh, this one. Yeah. Okay, so we did the function here. Inverse is page, where is it? Yeah, this one. Page 8. Okay, so remember this one. You guys can turn to page 8, take a look. So inverse is to use the x as y, right? Use the y as x. You switch x and y, right? So we have 3 steps to find inverse, okay? So now let's go back to that page again, okay? Log, okay, over here. So we are going to do the same steps, okay? So first step is to let f of x as y, okay? So over here, our goal is to find the inverse, okay? Find the inverse. And then state the domain, okay? So domain has to do with the restrictions. Domain of the inverse. So on the right side, you can see the 3 steps already, right? Step 1, let f of x as y. So we'll write it like this, y equals 2 to the x, okay? Step 1. Step 2, switch x and y, right? So the moment that you switch x and y, it's already called the inverse, all right? So this is inverse, but but we usually like to isolate y, right? So here we'll use the counter clock, change to log form, okay? So step 3 is to do the counter clock and change to log form. So we'll start with base, right? So log base of 2, right? And then go to the other side of the equal sign. So that's the x. So of x equals to y, right? So we'll write y equal. Okay, so this one is the inverse. The one in the box is the inverse. The one in the second line is also inverse too, okay? But we prefer to have y isolated, okay? Any questions? Can you raise your hand if you get this, okay? If you understand these 3 steps, can you raise your hand? Okay, very good. So now let's look at the domain, right? Domain is the x value. So right now you can see the x is on the inside of the log, right? So remember, inside of the log, you must keep it positive, right? Look at the restrictions. So inside is x, so we'll write the domain, okay? Domain. Domain you see in x, right? So x must be greater than 0. Remember, no equal sign, right? Must be positive. So that's it, okay? The 2 answers, right? One is to find the function, right? The other one is get the domain. Okay, so I would like you to try question B by yourself, okay? So find the inverse. This one is a little bit different, but I think you can handle that, okay? So once you get the answer in the red box, whether or not you think you get it right, okay, you can raise your hand, okay? Then we can go over the steps. So just simply follow the 3 steps. And then write the domain. If you get stuck, okay, you can also raise your hand, okay? So I know you've tried. Okay, I can do the step one, right? Step one is very easy. Just write out the y. Step two is pretty easy too, right? You just swap x and y. Okay, please raise your hand if you finished. Okay, how do we do counterclock here? Anyone? Cindy, what do you have for your final answer?
Y equals log base 1 over 3x minus 1.
Like that?
Yeah.
Yeah, okay. Anyone else got different? Ray?
Right.
Yeah, do you have the same or not? Ray?
Yeah.
Yeah, okay. So let's quickly go over the answer, okay? We start with the base, right? Base is 1/3. So log, base 1/3, and then counterclock. Counterclock, you have to go to the other side, right? So of x, right? And then equals to the exponent, so y plus 1. But since we need to isolate y, right? So you have to move the plus 1. That's the extra step you need to do. And just to be clear, the minus 1 is not in the log. Otherwise, you will put a bracket, right? But it's not attached to the log, okay? So we need to, let me erase that, okay? So we need to clear, and to show that, you can draw a bracket here, okay? So you know, so it's very clear that inside the log, there's only x, okay? So leave the answer like that. And once again, because the inside is only x, right? Inside positive. So x greater than 0. All right, so let's look at the next one. So based on the two example we had, A and B, okay? If you want to start finding the inverse, you need to make sure the form is in exponential form, right? Exponential form means it has left side, the y, right? And then the base, and then exponent, right? Nothing else. It has to be just 3 brackets to start with, right? This part, okay? Same thing with the question B, right? You have the other side, which is y, and then base, and then exponent. You have to have the 3 parts, okay? So what's different for question C is that it has an extra minus 1, right? If we do step 1, right? This one, it doesn't have the look of exponential. So how can I rewrite it so that it looks like an exponential function, right? Look like the 1 base, right? one exponent, and then everything else on the other side. How can I rewrite it? Anyone? Donna, what do you think? Do you understand what I mean?
Can you put the -1 to the left side?
Yeah, very good. Okay, so we will move the -1 to the other side, so it will look like y minus 1, right? And then base is still 3 and then 2x. So now it's ready to do the inverse, okay? So you must make sure if the question doesn't look like exponential, right? Sometimes you need to move things around. Anything movable to the right, to the y side, you move it over, okay?
Should it be y plus 1?
Yep, y plus 1, thank you. Thank you, Eric. Okay, so I'll let you take over from here to finish step 2 and then isolate y. Okay, so when you finish the answer, please raise your hand. I can show step 2. Okay, swap x and y. Don't forget to write the domain. Even if you're not sure if it's right, okay, please also raise your hand. All right, let's check the answer, okay, see what you got. Donna, what do you have?
The final
Yep, final.
y equals 1/2 log base 3 of bracket x plus 1 bracket.
Yeah, thank you. Tiana, how about you? Any trouble?
No, I'm still working on it.
Okay. Eric, do you have the same or different?
I have the same.
Same thing? Okay. So if I do the counterclock, right? I will start with log. Base is 3, right? So I write 3. And then go to the other side. So the other side is x plus 1. So make sure you put everything inside equals to the exponent, so 2y. Right? But we need to isolate y, so we need to divide by 2. So you could either write it as log and then all over 2, or you can write it like Donna, right? Put a 1/2. It's the same thing. Divide by 2 is same as multiplying by 1/2. Okay? Now let's check the domain, okay? What do you have for domain, Cindy?
X is greater than 0.
X is greater than 0. Anyone else got different? Did everybody get X greater than 0?
X is greater than -1.
X greater than -1. Anyone else? How about Eric?
I also have X is greater than -1.
Okay, so Cindy, yeah. Okay, how do we find the domain? How did you find greater than 0?
I don't know. I just put it down.
Oh, because you follow the other two questions? Is
Yeah.
that why? Okay, you have to remember that the rule was inside, right? Inside must be greater than 0, not just X, right? I use the word inside. So whatever inside the bracket, you must keep it greater than 0. So look at your answer, right? What's inside the bracket, Cindy?
X plus 1.
Yeah, so you have to grab everything inside, which is X plus 1. You make it greater than 0. Okay, and then what do you do?
Move the 1.
Yeah, okay, so then answer will be greater than -1. Okay, so make sure it's not always greater than 0. Okay, greater than 0 is for everything inside. All right, any questions? Okay, we have one more. Okay, one more to try. Right, so this time I'll let you start with the whole thing. Okay, so turn it into the 3 brackets first. Right, exponent, base, and the other side, and then carry out step 1, 2, 3. All right, and then domain. Okay, so hopefully this time you guys can get 100%. Okay, so you start by moving things that's movable to the y side first. All right. I will do step 1 for you. Okay, and then you got to write that out first, right? Fill in the things in the brackets, and then step 2, step 3. So same thing, please raise your hand. Either you get the answer or you don't, okay? Raise your hand. Okay, I want to check the step 1, okay? Make sure everybody has the same thing in the brackets. Donna, do you have the step 1?
Wait, what's that one?
Inside the 3 brackets?
Oh, yeah.
Okay.
Y minus 3 equals -2 to the power of exponential.
Okay, be careful here. Eric, what do you think? Is there anything wrong here? Or is that the same thing that you did?
Okay. That's the same thing I did.
Same thing you did. Okay, okay, so everybody hold on, okay? So take a look. Anyone else got different things in the brackets? Huh?
Is it the negative?
Okay, let me ask Cindy, okay? Did you want to say something?
Oh yeah, I said I moved the negative.
Yes, okay, so because well, I zoom in too much, okay? The negative, it doesn't have a bracket like that, right? So the negative is not attached to the 2, okay? So that's a very tricky part, right? So negative is movable. So you got to move the negative to the other side. So your base is a 2. And then negative goes over, it will make it negative y plus 3. Okay, so your first step is very important, right? It will affect everything after that, right? Right, so after this, you can do switch x and y. I can do that. So negative x plus 3 equals to 2, y plus, minus 1. Okay? And Tiana, can you tell us what do you have after counter clock?
Log 2 bracket negative x plus 3 bracket plus 1.
Okay, plus 1. Okay, very good. So you already moved the minus 1 over, right? Okay. Last thing is the domain. Okay, so I'll let Cindy try this again. Okay, Cindy, what do you have for domain this time?
X is greater than 3.
X greater than 3. Anyone else got differently? Did everybody get X greater than 3? E-Ray, did you get the same?
Mm-hmm.
Yeah? Okay, no one got different, huh? Then everyone's wrong. Oh no. What's wrong? What's wrong? Come on, I'll let you try again.
X is less than 3.
Oh, okay. Why is that now? Why is it become less than 3 now?
Because like when you divide by a negative, you have to like switch the.
Yes, very good. Okay, so be careful here. So this time, everybody remember to use the inside, right? But then there's another trick. It's not really tricky, right? It's just seeing if you remember that rule. Inside, right, which is that greater than 0, you can move the negative x over. That's faster, right? Or if you move the 3 over, then you would have negative x greater than negative 3. Whenever you divide by negative, you need to swap, okay, or flip the sign, okay? So it should be less than 3, okay? I've chosen questions so you can see different kind of questions, right? So, or make mistakes so that you don't make the same mistake in the future, right? So each question has its own purpose, all right? Okay, so let's move on. Okay, so now you know that log came from the inverse of, is the inverse of the exponential. And then for inverse function, if you want to get a graph, you just swap the x and y points, right? So if we know how to graph exponential, shouldn't be any problem graphing log, right? So that's what we're going to do. So you can look at our previous page on exponential, right? Or you can just work on the spot here, okay? So same thing, the base is also divided into 2 kinds, okay? So let's look at the example we have. One is y equal 2 to the x, as an example, right? Y equal to 3 to the x, it will look similar, okay? Will also be increasing. Let's write that down, okay? Greater than 1 is increasing. And the points that we are going to choose is just like before, okay? Same thing with the right-hand side, between 0 and 1. Okay, we'll do between 0 and 1 later, okay? Let's complete this one first. So can you fill in the y, the table for y, and then raise your hand, okay? Raise your hand when you finish the table. Okay, Eric, can you tell us your points?
0.25, 0.5, 1, 2, 4.
1, 2, 4. Okay, so 0.25 is at 1 over 4, right? So let's plot those. -2, 1 over 4. -1 is half. 0, 1, 1, 2, 2, 4, right? And then we also have an asymptote line, okay? So you can extend, right? Because it's right on the x-axis. So extend your asymptote line so we can see it. So the graph will go like this. Okay, I think when x equals to 3 will be 8, right? So if we draw one more point, it will be up there. Okay, so we'll continue from there. So as you can see, it's increasing, right? This should be a review. And then the equation of asymptote will be what? What's the equation of asymptote, Ray?
X is 0.
X is 0 will be the vertical line.
Oh, Y is 0.
Yeah, okay. The way you can remember is you think about every point on the axis, right? If you pick any point, look at all the green dots, right? And you try to write their coordinate. It will always be something 0, right? The y value stays on 0. That's why it's called the y equals 0. Okay, so look at the points, then you won't confuse. So y equal to 0. And Cindy, domain and range. Cindy, what's the domain and range?
I
Huh?
didn't say it yet.
Yeah? What is it?
X equals all real numbers.
Yeah, x anything. Range?
Y is greater than 0.
Yeah, okay, so it's above the x-axis, right? X-axis is y equal to 0, so it's higher than y equal to 0. Okay, x-intercept. Tiana.
There's none.
And y-intercept?
Y equals to 1.
Yep, y equal to 1. Okay, very good. You can write either y equal to 1 or you can write it as 0, 1, okay? Because y-intercept means x has to be 0. Okay, so this one is a review of exponential function. And since we know that its inverse will look like the log, right? Look at the left side, we did it over here, question A, right? We started with y equal 2 to the x, and then you found out if we follow the inverse steps, switch x and y, we get y equal to log base 2 of x, right? So they are inverse to each other. So that means the points will swap. So -2, 0.25, they will swap. It becomes 0.25 and -2. Okay, so all the x will become the y, all the y becomes the x. Okay, so we can easily fill in the table now. Okay, and then 0.5, right? 1, and then 2, 4. And then it will also have an asymptote at different place. Okay, so can you please follow the table, draw the points, okay, and connect the lines. Okay, when you finish graphing, please raise your hand. X and Y switch plates. 0.25, -2 should be down here. 0.5, -1, 1, 0, 2, 1, 4, 2. If you want to graph one more, right, it will be 8, 3. Okay, please raise your hand if you finish drawing the graph and the asymptote. Okay, don't forget the asymptote as well. Okay, you can continue, write out the properties. Okay, fill in the properties. Okay, I will complete the graph. It'll go like this. Right? So it's also getting higher, right? As you can see, if the base is greater than 1, it doesn't matter if it's exponential or logarithmic, right? The both function, they are getting higher as we move to the right. So they both belong to increasing, okay? Now let's check the asymptote now. Asymptote this time, it looks like it will be this line, right? So make sure you extend it. So what's the equation for this line, Eric?
Of the asymptote,
Yep, of the
x equals 0.
Yep, very good. Okay, x equal to 0. So this time we have a vertical asymptote. Okay, and what's the domain and range? Donna?
Domain is x greater than 0.
Yeah, range?
Where r y equals all real numbers.
Yeah, okay. And then x-intercept and y-intercept. Cindy?
X equals 1 and y is none.
None. Okay, so you can see if you compare with the table above, right? For exponential is y equal to 0, now it's x equal to 0, right? Because inverse, everything swap. Used to be the range, it becomes the domain, right? Range was y greater than 0, now it becomes x greater than 0, right? Try to compare. So you don't really need to memorize it, right? You already know exponential, you just know the original one, then you get the new one. Same with the intercept, right? They also get swapped. And also make sure your variable is also swapped as well, okay? So that's how we do the increasing. Decreasing can be filled out in a similar way, okay? So that's why I only do the one side, because the right-hand side is for you to do it, okay? So between 0 and 1, it will be decreasing. Right? So I chose 1/2 as an example, right? And then the bottom one, the log, also has a base of 1/2. So both of them, if you draw it correctly, they will both show decreasing, right? So please complete both tables and the graphs. And when you finish both, please raise your hand, okay? The x value will start with the same thing, okay? -2, -1, 0, 1, 2. Okay, I want to check the values for table. Okay, Tiana, can you tell us your y values?
4, 2, 1, 0.5, 0.25.
Yep, very good. Okay, so it's the other way around compared with the increasing. So right away, you could get the table for the inverse, right? Because they're upside down. Okay, -2, -1, 0, 1, 2. Please raise your hand if you finish the graphs. And their properties are the same, okay? Compared with the increasing ones. So -2, 4. So gets lower and lower as we move to the right side, right? So it's called decreasing. Okay, and then asymptotal line, same thing. For the decreasing of the log, 4, -2, 2, -1. So it's decreasing in a different way, right? Please raise your hand if you finished. Okay, we have vertical asymptotes. Okay, so these are your basic graph. Okay, remember in transformation, you have different kinds of basic graph. Now you know how to graph log. So we could apply RST to the log as well, okay? So when you get a question, the first thing you should ask is whether it belongs to the increasing one or the decreasing one, right? You look at the base, then that will tell you which one to start with. Okay, so we'll try 2 questions, and one increasing, one decreasing, okay? And then we can look at something else, okay? So look at next page. All right, so over here we have 4 graphs, okay? So let's try question B and C, okay? So those are the harder one, right? If you're able to do the harder one, I think easier one should be okay, right? So let's look at question B. We have several things to do, okay? We need to sketch, find the domain range, right? So 1, 2, 3, and then asymptote, number 4, okay? 4 things as your answer. Okay, so let's start. So is this one belong to the increasing or decreasing? What do you think, Eric? Is it increasing or decreasing?
Increasing
And how do you know?
because log is 10.
Yeah, okay. It doesn't show the base, so it means the base is a 10, okay? Invisible 10. And 10 is greater than 1, right? Base greater than 1, increasing. So once you know it's increasing, then you will start with y equal log x, right? The graph of this, the increasing for log, okay? See if you remember the look, right? It has vertical asymptote line and increasing, so it goes like this way. Okay, so this is what you start with. Okay, so first thing is to identify increasing, decreasing. After that, now we need to know the story. Okay, so R, S, T. Okay, so if you need, you can turn into story form. Or if you are able to tell RST without changing the story form, that's okay too, okay? So please write out the story, RST, reflection, stretching, shrinking, translation, okay? After you fill those out, can you please raise your hand? If you forgot what RST means, okay, you can raise your hand as well, right? As we go over, I'll help you remember, okay? Okay, Donna, do we have reflection here?
Yeah,
What kind?
reflect on
Re-
y-axis.
Which axis?
X.
X-axis. Okay, very good. X-axis. Okay, the negative can be moved to the y side, right? So it's negative y reflect over x-axis. Okay, stretching, shrinking. Eric?
None.
None. Okay, very good. Translation, Cindy? Do we have translation? Cindy? Are you there? Cindy?
Oh, sorry, I forgot to mute myself.
Okay.
Down 1 and right 2.
Down 1 and right 2. Down 1, right 2. Anyone got different? E-Ray, what do you have? E-Ray? Yeah.
Up 1 and right 2.
Up 1, right 2. Oh, you said right 2, yeah. Right 2. Okay, so is it down or up? Okay, the way you tell you need to move it to the turning to story form. Okay, let's double check the story form. Plus 1 goes to the left will be minus 1, right? Divide by negative equal to log x minus 2. If you see a minus, right? You see a minus, the direction means either right or up. Okay? You have to go back and check the transformation chapter, okay? The second chapter. If you see an adding, okay, it means left and down. I'm talking about story form, okay? After you move things over, then you apply the rule, okay? Subtract is up and right, okay? So it should be this one, okay? Up and right too. Okay, so now let's draw the graph. For the graph, I don't need you to have a full table. I don't need to see 5 points, okay? All I need is the we don't need intercept here, right? Let me see. Yeah, we just need 1 point, okay? The most important point is the original x-intercept, which is here, right? 1, 0. I need to know where it goes. Second thing you need to show is the asymptote line, right? Where it goes. So we need to find that out, okay? So let's start with y 1, 0, right? This is the original point. If you reflect over x-axis, then that point will stay the same place, right? Because it's already on x-axis. How can you flip it, right? And then we're gonna move it up and move it to the right. So what will be the final location for that point then? Okay, Tiana, where is the final place? After up 1, right 2.
Is it 3 and negative 1?
3, but you are moving up though, up 1.
Oh, plus 1?
Yeah, so 0 plus 1 will be 1. Okay, so we will go to 3, 1, right? So let's go to here. We'll plot it out, right? 3, 1, the point will be here. Okay, and then we have asymptote line, okay? If I reflect that asymptote line over x-axis, it will still look the same, right? You flip the y-axis upside down, it's no change, right? So remember, reflection does not affect the asymptote, okay? Same with the stretching and shrink, okay? So the only thing that's going to affect the asymptote is the translation. Moving it up 1 is still the same line, okay? Same location. It's only moving left and right. It can make it change, okay? So here we're moving it right 2. So go to here. Okay, so now we have our point and the asymptote. Now the only problem is how to make the curve, right? Because we only get 1 point, okay? So which way would the curve then? Then you need to think about the story, right? What has happened? So what you could do, right, is to make a little comic strip. First, we got reflect over x-axis, so goes upside down, right? Instead of increasing, now it becomes decreasing. And then moving it up and right, so it'll be somewhere there. So by drawing the little comic strip, right, we know that the curve has to be going decreasing. And that will be all I need to see, okay, on your homework. You just need to show me where is 1 point, right, the final location of the point, and also the way it curves, of course, the asymptote too, okay? Okay, so that's it, right? So that's a graph. Now we can use that to answer our domain range and asymptotes. Okay, equation of asymptote. So when you finish the 3 things, please raise your hand. Equation of asymptote, domain, and range. Okay, let's check domain. Donna, what's the domain?
X is greater than 2.
Greater than 2. Okay, very good. Range? Ray, what's the range?
All real numbers.
Yeah. equation of asymptote, Cindy?
X equals 3. Wait, no, 2. Yeah.
2. Yep, very good. Okay, so the numbers will be the same as use the one in the domain. Okay, and another way to think about the domain, right? It's like looking at the x value, and you can see in the function inside you see x minus 2, right? Because sometimes you don't need, sometimes they don't need you to graph and still ask you the domain. How can you do that without graphing it? So you need to look at the inside, right? Inside you see x minus 2. So remember, inside has to be positive, right? Greater than 0. So from there, you can get the domain as well. Okay? Any questions so far? So question C will be similar, okay? Except it's a decreasing one, right? As you can see, right? This one has a base of 0.5. That base is between 0 and 1, all right? So this one has a decreasing to start. So log base 0.5, okay? So this one is the decreasing one. Decreasing looks like this, okay? So you could change this to story form first, okay? Make it into story form, and then write the RST. After that, you can write the domain, range, and asymptote, and also draw the graph, okay? I will check the story form before you do RST, okay? So please write out the story form and raise your hand, okay? It will affect everything, right? If story form is wrong, RST will be wrong. Does anybody forget the story form? You have to make and move things over to y side, right? Raise your hand if you got the story form or you forgot, okay? Okay, Tiana, do you have the story form?
Is it y plus 2 equals to log 0.5 bracket 1 minus x bracket?
Okay, 0.5, 1 minus x bracket. Okay, close, pretty close. Okay, the only thing is on the inside, the variable has to be at the front, right? Just like the y plus 2, the y has to be at the front. So anyone else? Eric, what about you? What do you have?
I got the same thing, but with negative x plus 1.
Okay, negative x plus 1. Okay, so we can swap them around, right? That's better. Okay, but not 100% yet. Right now it's like 99%. What else do we need to do? Anybody? Cindy, do you remember?
No.
Okay, Donna, how about you?
Negative, like bracket,
Mm-hmm.
negative bracket x, negative 1 bracket.
Okay, so the problem here is the minus, right? If you want to get story form, the minus cannot be attached to the x. So you have to factor it out, okay? You can go back and check the transformation, how to get story form. So y plus 2, that part is done, okay? Base is 0.5, so negative will factor it out, and then the inside will become x minus 1. So this will affect your translation, right? If you did not factor out, it looks like plus 1, x plus 1. Then that will be wrong, right? So you got to take it out, make it x minus 1. So that is our story form. Okay? So it's a good chance, right here to review our story form. So please use this one and write out the RST, and then we'll check again, okay? So raise your hand if you get the RST. Okay, Elaine, what's the reflection?
Over 1.
Okay, over y-axis, very good. Stretch, shrinking, Cindy?
None.
None? Yeah, very good. Okay, you will have stretch and shrinking if you have anything multiplied with the x, okay, or divide with the x or y. Something like question D, that one will have stretching and shrinking, okay? Now, translation. Eric, what's the translation?
Down to left 1.
Down to and where?
Left.
Left?
Or right.
Yeah,
Or
right 1. Okay, remember subtraction. Okay, let's go back up again, right? Subtraction is either up or right. Okay, we're talking about while in story form. Okay, now next thing is we need to get a point before we can graph it. Okay. So the point to start with is always 0, 1. Sorry, 1, 0. Okay, so please tell me where it goes. Okay, so raise your hand if you get the new location of the point. When you are trying to get a new location, okay, you could either follow the RST or you could look at the story form, okay? For me, right, personally, I like to use the story form because whatever you see with the x, then you apply to the x, right? Whatever you see on the y, you apply to the y. But at the same time, you also need to think about story, okay? Otherwise, you will be doing the wrong operation. Okay, and then if you like, right, if you already got a point, right, you could also think about the comic okay? After reflection, what it looks like. After translation, what it looks like. Okay, please raise your hand if you got a point. Okay, Donna, where's the point?
0, -2.
0, -2. Okay. Cindy, how about you? Any trouble?
Oh, no, I got the same.
Got the same, okay, because you didn't raise your hand. I thought you had trouble. Okay. Right, and then, so let's check here, right? See if it's right. We'll do step by step, okay? If you look at the story form, you have a negative, so you got to multiply by negative on the x, right? And then -1, 0. After that, you do the moving, right? Moving to the right, and then moving it down, okay? So that's the correct point. Now let's look at the comic, okay? Reflect over y-axis, so it should look like this, right? And then moving it down and right, so something like that. Okay, so that should be your final graph. So please complete the graph and fill out the 3 things, okay? Domain, range, asymptote. Okay, so once again, raise your hand if you finish the whole thing, okay? Graphing, domain, range, asymptote. Okay, I'll draw the point, okay? 0, -2. Okay, let's check the location for the asymptote line. So where is the, what's the equation of the asymptote? Let's get that first, okay? Equation of the asymptote. Eric,
I don't know.
okay? How about Tiana?
Is it x equals to 1?
Yeah, x equal to 1, okay? So remember for asymptote, okay, as I mentioned before, the asymptote, it will not be affected by reflection and stretching, okay? Because no matter how you reflect, the asymptote will always stay on the uh, y-axis, right? Because it's right in the middle, right? So if you flip upside down, it's still there. If you flip left and right, it's not going anywhere. It's right in the middle. And stretching, shrinking, it won't affect that as well, right? Because it's anything you multiply, it still stay on the same line. The only thing make it move is the translation. So you just look at the translation, okay? And because it's a vertical line, the only way to make it look at make it go to other places is moving left and right, and we are moving right 1, so that's why it's x equal to 1. Okay, understand, Eric?
Yeah.
Yeah. Okay, so just focus on translation and you can get the asymptote line. Now we need to know how it bends, right? So you look at the comic, it looks like it has to go downwards, right? So downward to the left side, so it looks like this. And that's all you need to show me, okay, on the homework. Okay, last thing is domain range. Cindy, what's the domain?
X is greater than 1.
Okay, how about range?
Y equals all real numbers.
Y is a real number. Okay, don't mute yet. Okay, don't turn on your mic. Okay, remember we mentioned about how to find domain without a graph, right?
Mm-hmm.
Okay, how do we find domain? Just by looking at the function.
Use the bracket.
Yeah, use the bracket, right? And then what do we do with the brackets?
Greater than 0.
Okay, so 1 minus x greater than 0. How do I solve for x now?
Move 1 to the other side.
So what should I write?
X is greater than 1.
You mean you move the 1 to the other side? Is that what you mean?
The 1 and the negative.
So can you tell me one more time? How do I write it?
X is less than 1.
X?
Is less than 1.
Oh, x less than 1, but okay. So you are moving the 1 over, right?
Yeah.
Are you moving the 1 over?
Yes.
Okay. 1 goes over, you should write it as -1 on the right side.
Yeah.
And then what's on the left side then?
Negative X.
Yes. Okay. And then you divide by negative, makes it flip. Okay. Then you become less than 1. That's one way to do it, right? The other way is just simply you can move the negative x to the other side. That also works too. Okay. Will be faster. So your domain should be what, Cindy?
X is less than 1.
Yeah, you look at the graph too, okay? One is over here, right? X equal to 1. The graph is on the left side. Left side means it's getting smaller, okay? So based on the graph, you should also get the same answer, less than 1, right? Or you can figure it out without a graph. Okay, so you can double check, right? If you get something on the graph different from the brackets, right? Then you know one of them is wrong, right? Okay, one more little things, okay, before I let you guys go for break, is the domain, okay, which we've been practicing, okay, several times now, right? So you need to make sure the inside is positive, okay? It's not always just greater than 0. You got to move things, right? You got to do some algebra. So that's one part. You look at the inside. The other thing is, what if you get variable? That's on the base. Okay, this has never happened before, right? You can see the variable is on the base. So you need to know the restrictions on the base. Does anybody remember what was the rule? We mentioned that today, okay, at the beginning of class. The rule for base. Okay, time to flip back, okay, find the answer. What's the rule for the base? Donna, do you remember?
The base
Mm-hmm.
greater than 0,
Mm-hmm.
but it's not equal to 1.
Yes, very good. Thank you. Okay. So this one came from, okay, if you couldn't find it, up here. Okay, page 104. base between 0 and 1, base greater than 1, right, means the increasing and decreasing, right? But then a better way to say the same thing is just to say base has to be bigger than 0. And we skip 1, right? You see a number line? We skip 1. So we're gonna use that over here, okay? Because we have variable in the base. That's why we need the rule for base. Okay, so based on this, we have x, right? Because base is x greater than 0, x cannot equal to 1. Okay, can you raise your hand if you understand everything up to here? Any questions, Samantha and Ray? Okay, so that's for the base only. Okay, we're not done, right? We're talking about domain. Domain is any place that has x. You have to consider, right? So that's one place. Now let's look at the other place that has x, which is the inside, right? That's the easy part. We've been doing that many times. Right? Inside must be greater than 0. So inside here we see is x minus 2 greater than 0. So from here we have x greater than 2. Right? So that's the first thing. And then this is the second thing, right? But then your domain, you have to choose the part that both of them works. So we are going to draw a number line to find the final answer, okay? So first I will draw the green, okay? I'll use green. Green for number 1. So green is greater than 0, cannot equal to 1, right? So that's what it looks like. And then I'm going to draw the blue one, or actually let's use the purple, okay? So purple one, okay? For number 2, x greater than 2, right? X greater than 2, so 2 is here. Greater than 2, so I have to make it go to the right side. So the part that they both work will be your final domain, right? Because domain is something that's okay to use for x value, right? So it cannot just work for one part and doesn't work for the other, right? It has to work for both. So the part that they both work will be the red shaded part. Okay, so the final answer for domain, how do we describe the red part? E-Ray, what do you think? How do we write the domain now?
X is greater than 2. I don't know.
Okay. Yes, okay, so you write it as x greater than 2. So you only pick the part where they overlap. Okay, so be careful here. If you only need to do this much work if you get x in the base. Otherwise, you just focus on the inside. Okay. So we have one more question. Okay, let's just try question B. If everyone gets it, then we have a break. Okay. So please carry it out. Find the domain. Okay, raise your hand. Okay, when you finished. So same thing, okay? I'm gonna use green and purple, okay? When we go over it. Okay, you probably have the base part. Let's check the base, okay? Cindy, what do you have for the green, for the base?
X is greater than 0, x cannot be 1.
Oh, that's if you have base as x, right? You have to follow the word. Whatever in the base, right? You have to make it greater than 0, not equal to 1. But right now the base, what do you see in the base in question B?
3.
Yeah, so you have to use x plus 3, right? You got to adapt, right, to the question.
X is greater than negative 3.
So x is greater than negative 3, and then?
X cannot be 1.
No, you have to use base, not x.
Base, yeah, base cannot be 1. So x plus 3 cannot be 1.
Yeah, so what's x cannot be then?
Negative 2.
Yes, okay, so that's how you adapt, okay? Different question can change. It could be next time maybe you see a question that's 5x minus 4, right, in the base. So you got to do the same thing. So that's why I said you have to use base greater than 0, right? The rule is base greater than 0, base not equal to 1. Instead of x greater than 0, x not equal to 1, right? Base can change. So that's for the base part. Now let's look at the inside. Okay, Tiana, do you have the inside?
X is less than 2.
Okay, very good. X less than 2. All right, so now please draw the 2 lines. Okay, 2 lines and then find the overlap. The green is 1 line, okay? Not 2 lines, 1 line. And the purple one is another line. Okay, please raise your hand if you got the final answer. Negative 3, we have negative 2, we have the 2 for the purple. Okay, Donna, can you try to draw the green line on the graph? Are you able to draw it? Yeah? Okay. Okay, very good. Very good. Okay, so that's a green one. All right, and then the purple one. Ray, could you draw the purple one? Okay, very good. Thank you. So purple goes from here, going to the, oops, going to the left side. Okay, so the shaded part will be everywhere they overlap, right? So how can we write out the answer then? Eric, how do you write the answer for the red?
I did it wrong. I accidentally did -2, so I'm changing my answer right now.
Okay, that's okay. Let me ask Cindy, how do you write your answer then, if that's the red?
I wrote it like -3 is less than x less than 2.
That's it?
X cannot be -2.
Yeah, very good. Okay, can I go to -2, right? Because at -2, it doesn't have an overlap, right? The purple one has -2, but then the green one doesn't have -2, right? You only find the part where they both have the points. Okay, so if you have any question about anything up to now, you can stay during the break. Okay, we have a break now, and I'll see you guys at 6:45. Okay, and get your book 2. We'll be using book 2 after the break. Okay, bye-bye.